Did. So you let f be the function that is continuous on the interval from 0 to 4. All right. The function is twice differentiable except at x equal 2. So x equal 2, something weird's going on because when you take the derivative of it, you get an undefined value, does not exist, or dne or whatever. The function f and its derivatives have the properties indicated in the table, where dna indicates that the derivatives of f do not exist at 2, which they already said that basically. It's non-differentiable there. So they're saying the derivative is positive, positive, negative, negative, which tells, what does the derivative tell you about the original function? Where it's increasing and decreasing. What does the second derivative tell you about the original function? Concavity. So that pretty much should be everything you need for this problem. Part A, from 0 to 4, find all the values of x which x has relative extrema. So we're going to look at the first derivative. So is there a relative extrema at 1? No. Is there a relative extrema at 2?
Yes.
Yes, and here's why. I know it's undefined for the derivative, but is it undefined for the original function? No, it is not. So it's just a point of non-differentiability, which means it's not a discontinuity. It's probably a corner, a cusp, or a vertical tangency. It's not a jump, it's not a hole, and it's not a vertical asymptote. It's either a corner, cusp, vertical tangency because it's defined for the original function. It's undefined for the derivative only. So it has a relative what at 2? Because it goes from positive to negative. It has a relative max. What about at 3? Nothing. So the only thing you got for part A is you would say at x equals 2, it is a relative max because the derivative goes from what? Positive, negative. That's it.
What about the endpoints?
That's relative extrema. We're not finding absolute extrema. The only time you worry about the endpoints is when we're doing absolute extrema. If they do relative, you only got to check critical values. That's a good clarification. So everybody listen. When they're asking for relative extrema, you only check critical values. When we do absolute extrema, that's extreme value theorem. Then the function has to be continuous. Here's another reason, Josh, we wouldn't even be considering extreme value theorem because, no, we would. We could. Because it only has to be continuous, and the function is continuous. So, but they didn't ask for absolute. So if they ask for absolute extrema, you have to check endpoints and critical values. But when they do relative, you only check critical values. So very good question. Yes?
Do we know that they're critical values because they equal 0 in DNE, or is 0, 1, and 3?
You know the critical values for the first derivative are 1 because it's 0,
and
2 because it's undefined, and 3 is not a critical value for a first derivative.
Okay. So you look at the value and just find if it's 0.
So 3 we wouldn't even consider anyway, would we?
No.
Because 3 is not a critical value for the first derivative, so 3 wouldn't even have been a relative max or min. Even if it would have been from negative to positive, I didn't even pay attention to that. I could have possibly got that wrong because I didn't look.
So in this, does it mean that 1 is a double root, or because it goes, the signs are the same?
It means that probably, yep, that means it would have been a double root.
Okay.
Okay, very good. Which means up here it would have been a triple root because if it shows up as a 0 in the first derivative and second root, it went from a triple to a double to a single. Which that doesn't really matter too much. Part B, on the axes provided, sketch the graph of the function f and all of the characteristics. Is there a part A, B, and C, or and a D, or there's a D? So this is probably only worth 2 points, answer and the reason. So again, you would have said x equals 2 because the first derivative, f prime, goes from positive to negative. That would have been the only one. On the axes provided, sketch the graph of the function that has all the characteristics. You know the first thing that I would do sketching that graph? What's the very first thing I should do? Nope. Put all the points. Put all your position points. F of 0 equals what? Put that as a point. F of 1 equals what? 0. Okay? F of 2 equals what? 2. That's probably going to be my corner and my cusp, something like that. F of 3 equals what? 0, and F of 4 we don't know, do we? And we don't have to know because it's open at 4. So that's all the points we know, that's it. So now let's just pay attention. It's got to be positive, positive slopes. So it's increasing all the way up to 2, and then it decreases after.
But then you have to look at concavity.
Then we're going to have to look at concavity. And that's where it says all the characteristics. It says sketch all the characteristics of F. So you can't just do the increasing and decreasing. You got to get the concavity right. So it's concave what first? Down. So it probably does this, and then it's a slope of what there? 0, so it better be a horizontal tangent there, like a disco curve. Slope of 0 right there. We know that because it won the derivative 0. Then it's concave what? Up. And then it's concave what? Down. And then what is it?
If it's
there a
concave
tangent
down.
there?
it's
You
concave
gotta
down.
slope it a little bit.
That's concave that top.
Oh, concave. What is it right here? So 2, 2. Okay, so this is concave up, right? What's the next one? Next one's concave down.
So how do you make that
Okay, concave down.
does
That?
that have to equal the slope of that arrow right there?
But there's no slope to 0 there. It's a slope of what?
At the other point, how did you know that you had to make it be
Horizontal tangent. Slope of 0.
over like that prime?
Yeah, more like F prime.
So the slope
And then what's the concavity stay? Stays concave what?
down.
No, it switches to concave
Yeah.
up. Sorry. So something like that. What now? If you have this, there is no concavity because it's lines. Cusp will probably have concavity into it. And remember, this guy looks like a shark fin. So let's check it real quick. Positive slopes, negative slopes, concave down, concave up, concave down, concave up. Looks good to me. And where were you supposed to stop it at? I guess I didn't have to go that far. 4, but you can just draw an arrow. Doesn't matter because they didn't give us a point at 4, but you can just stop it at 4 if you want. All right, part C. Okay. Part C, let g be the function defined by g of x is equal to the definite integral from 1 to x of f of t dt on the open interval from 0 to 4. So we're still using f of x. There's f of x still. This right up here, that table is still f of x. Okay? I'll have to zoom out a little bit here to get the whole thing so I can see it. All right, so the table is still f of x. From 0 to 4, find all the values of x at which g has a relative extrema. All right, here's g. If I want to find the relative extrema for g, what is g prime of x? F of x. So now, if I'm going to look for this is the exact same problem as part A. Exact same problem. But now, to look at the relative extrema for g, we need to look at which line? The top one. So I need to look at the top one here. So anywhere where you have slopes of 0 or undefined. So here's my 2 critical values, 1 and 3. That's it. Does everybody see that? Because that's slopes of 0 because g prime is f. So this right here, just remind yourself, now you're looking at g prime of x. And how do we get that this is g prime of x? We just did what? Plug x of that. X in for f of t, that's FDC part 1. Okay? Remember, it's the derivative. Let's just review this when I'm thinking of it. Derivative from a to u of f of t dt that rule is this. You plug u in, so it's f of u times the derivative of u, which is what? Du dx. But when it's an x, what's the derivative of x? 1. So when you plug in x, you just get f of x, but then times the derivative of x is just 1. If there's like an x squared there, then you'd have to multiply by 2x, which makes it more complicated. All right, so those are the possible critical values, 1 and 3. Is 2 a critical value for g prime?
No.
Why not?
Because
This is equal to 2. It's not equal to 0 or undefined there. So they want to know relative extrema. What is it at 1?
it's a relative.
Relative min. Why?
Because
Because g prime goes from what? Negative to positive. What about at 3? Relative max. Because g prime goes from what?
What if
Positive,
they say
negative.
because f?
You could say f because g prime is f. That would be okay.
The slopes of G change from.
You need to say which one. So if you say the min, you need to say the slopes change from negative to positive, and then if the max, you need to say slopes change from positive to negative. Just make sure you
Yeah,
get the correct
that's
order.
what I was
That's fine. Slopes is fine. You can use the word slopes, and that's totally fine.
Chop Kyril.
For the function g defined in part C, find all values from 0 to 4, which the graph g has a point of inflection. Justify your answer. So if g prime was f of x, what is g double prime?
F prime is prime.
So what are you gonna look at for points of inflection? Which line up there? Second line. So we're gonna look at this line. So possible points of inflection is where the derivative equals 0 or undefined. So a point of inflection could be at 1, could be at 2, and could it be at 3? No, why not? Because it's -3, so that one's out of the question. What has to happen for it to be a POI? Change in concavity. Do we change in concavity at 1? No. Do we change in concavity at 2?
Yeah.
Is 2 defined in the original function? Yeah, so we're good. As I said, it was a twice differential.
only POI.
That's the only POI.
No.
The only POI. So the only POI is at what? 2. Very good.
No, that
Justify your answer, you'd say it goes from what? You'd say G double prime goes from positive to negative.
17.
There you go. Done.
17.
Moving on. All right, try 5. Give you 5 minutes. Really try this one. This is one that students will tend to skip, and they look at problems like this and get a little more complicated, but let's give it a good try here. 5 minutes. Focus hard.
Can you zoom in?
Yeah, see.
I'm not